Okay, these are your notes for topic 3, lesson 1. This is all about the relationship between energy, force, motion, and work. So as you listen to this, as you listen to your notes presentation today, be filling out that note sheet that you grabbed when you walked into class. Okay, so energy in motion and force. So energy is the ability to do work or to cause change. And we're going to talk a little bit about what work actually is a little bit later on in this slideshow. So some examples of work, if you pick up your books, your backpack, etc., motorcycles or cars, they do work, they burn fuel. That changes that the energy in the chemical bonds in the fuel, changes it to the energy that's used to make the car or the motorcycle move. So they do work by burning fuel. That changes it into other substances and releases some energy. Forms of energy, there's lots of different forms. Energy can be in the form of light, sound, electricity, heat. Okay, we cannot see energy. We usually can just see the effects of energy. When we touch something hot, we can feel its warmth. So we don't really usually see that it's hot. We can feel that it's hot. Okay, the bass guitar, I can't see the sound, but I can certainly hear the sounds that it makes. So energy and force, and motion and force continued. Motion, so what is motion? The position of an object changes relative to another object. Okay, so if you're walking past a table, your position is changing in relation to that table. Okay, if you're both moving at the same speed, oops, let's go back. If you're both moving at the same speed, then there is no motion. So think of it like this. This is my train. This is a train. Okay. We have lots of trains in South Dakota. None really that you can ride on. So here's my train. If you are sitting in the train, here's you. Okay, you're sitting in the train. You do not have any motion compared to the train. So relative to the train, there's no motion. But if there's a tree over here, you are moving, you're moving this way. So you're moving relative to the tree. So you would have motion as you fly by in your train. Okay, so that's what motion is. It's relative from one object to another. Okay, I have to erase my train, otherwise it's going to show up on all my slides. Bear with me. Getting rid of my tree. Goodbye, tree. Okay, and so objects need energy to move. So we're moving into that relationship between energy and motion and then those forces. So if an object's going to move, it has to change its position relative to some other object. It's going to need energy to move. So for example, if you have somebody pitching a baseball, it needs energy for that baseball to move. That energy is going to be supplied by the pitcher. Or racehorses, they need energy to move. So that energy that they get to give them motion is in the food that they eat. So that food provides the energy that causes that allows that racehorse to move. So a force is defined as a push or a pull. Okay, and so we've kind of got this cause and effect relationship. So first we need to have energy. Energy can be in many different forms. So once we have that energy, we can apply a force that causes a motion. Okay, so this is a cause and effect relationship. We first have to have energy to cause a force to create a motion. Ooh, excuse me. Let's go back up. Okay. So forces and work. So how do these forces relate to work? So work happens when we exert a force on an object that causes that object to change its motion in the same direction which you exert the force. So when you do work, it has to be movement in the same direction of the force. Okay. So example, if you're carrying your books, there's little to no work being done because your force is not in the same direction as your motion. Okay. So work only occurs when that movement and the force are in the same direction. So work requires motion. If you don't move, there is no work. Okay, so this is what I mean. This guy is pushing a crate. His force is in this direction, okay? So it's to the right. The object is not moving, okay? So with a force without motion, there is no work done, okay? In this picture, when an object is carried at a constant velocity by a force which acts at a right angle to the motion, no work is being done. So he's applying a force, and that force is moving up. But his motion is to the right. So no work is being done. In order for work to be done, like if this crate started to move in this direction, then we would have some work. So to have work, we have to have motion. Okay, I have to have motion, and it has to be in the same direction as my force. So my force is going this way, my motion's going this way. Once this crate starts moving, then we would have work. In this one, our force is going up. That's not in the direction of our motion, so we can't call that work. When we have work, we have to have motion in the same direction as the force that we are applying. Okay, so how do we find work? We've been doing this for the past couple of days, so I think that you guys are pretty familiar with this. But to find work, the SI unit is joules. Work is going to equal our force times our distance. We measure our force in newtons. We measure our distance in meters. Okay, and so a joule is really a newton times a meter, so we call it a newton meter. That's that unit for work. 1 newton meter equals 1 joule. Okay, we've already done those math. So how work relates to energy and power. Both energy and work are measured in joules, okay? So we need to have energy to apply a force to create that motion. Our force and our motion need to be in that same direction, have work, and so we can measure both of these in joules. Power is how quickly you get your work done. Okay, so power is the rate of which work is done, and it equals the amount of work done on an object in a unit of time. Okay, so how fast work gets done, that is power. So our formula, we worked with this a little bit yesterday. Power is how much work you do divided by the time, and the amount of time that you do it in. Okay, so we can write this as either power equals work divided by time, or since work is force times distance, we can write it power equals force times distance over time. The units for power are watts, or 1 watt equals 1 joule per second. Okay. Power and energy. Power is going to equal the energy transferred over time. All right, these are your notes for energy, work, and power. You should have been filling in your note sheets this whole time. Then you're going to be doing a worksheet over lesson 1. You can use your notes. You can use your books.